Okay, okay, nice to be here. Hello, everyone. Good morning, good evening, good night. So, before I start, I need to be super glad because I prepare my cookies, my Jakarta cookies, as best I can do as programmer, software engineer. So, I did my best to prepare, and I create 11 to celebrate the new version of Jakarta EE. So as Ivar said, we're gonna cover here the future of enterprise Java, especially around its specification side, around the persistence side. With me, I have the call spec lead, Nathan. Hello, Nathan. How are you?
I'm good. How are you?
I'm fine as well. So shall we start? Okay, let's start about Jakarta Data, simplifying the persistence for modern cloud native application. So let's make it great. We usually, when talk about data, I love to talk more about history. So why we have a lot of data, why we handle a lot of information, and especially because the main goal of data is to make sure that it will endure for the whole humankind. And we can say that our first database belonged to the caves. Yes, we had cave as database. And then we moved to libraries because we put more and more information. And of course, we need to have more efficient way to organize, to write, and of course, to read that information. And then finally, we are living in a distributed data era with several configurations, several databases, several persistence layers, and so on. But okay, it is enough of philosophy, it is enough of history, but why do we care about database nowadays? Why do we care about this kind of thing? So why do modern application need data storage? I can summarize in just 3 points. Of course, there are more. Is where the state is, especially because when we talk about microservice, most of the time we are talking about stateless application, and the state needs to be somewhere. So the database is the place, is where the current opportunity of your company is. And also at the same time is where the new opportunities comes from. And what does that mean about that? For example, I worked in a company that's a bank, and they created a product that's a credit card, and based on the user historic, they could check that they could sell wine because a lot of credit card users also buy a lot of wines. This bank created a winery that became huge. I mean, the biggest one in Latin America for 3 months. So it's the state, current opportunities, and the future opportunities, especially when we talk about machine learning, data API, and things like that. And of course, data is aware. We have several flavors to work with that. So we do have SQL database where we have Postgres, MySQL, Oracle, and so on. We do have several flavors of NoSQL database with several types. Those one here is those the most popular ones. So white column, graph, document, key value. We do have more. For example, we have time series, we have multimodal. Right now we have vector database to handle with machine learn and store this machine learning information and so on. And of course, we are Java developer and we enjoy a lot to the integration and put quality inside of our application. And to make our life easier, there are several patterns like driver, active record, data mapper, data access object, or DAO and repository. And as you can see, these patterns might be close to the database, exploring more the data-oriented programming, or close to the application, going more to the domain-centric way. And yes, of course, talk about database is amazing, but today the goal is to talk about Jakarta data, right, Nathan? Especially because the main goal is, okay, it doesn't matter the database that I'm gonna use. I might use the same data patterns, like data access object, like repository, like CQRS, and so on. And that's what that was born Jakarta Data, to be these persistence patterns to make it easier to you to use and explore more the persistence layer. And for example, explore Jakarta persistence and Jakarta NoSQL. And as a first version, we will cover the repository patterns. So, and that is what we're going to talk today. And later, please tell us what the
All
core
right.
concepts around repository.
Yeah, so let's explore some of the API that we're standardizing in Jakarta Data. So it all starts with these core concepts that we have, and these are familiar concepts that you'll find in the industry, and we're largely seeking to standardize a lot of things and then build on from there. So you have the entity, which basically represents your data, and you have the repository that you're using to define interactions with the data, operations, on your entities. Let's go to the next slide. So we'll take a look at the entity model. And in looking at this slide, if this slide looks familiar, like it's something that already exists, it's basically because it does. This, this entity here could be an entity from Jakarta Persistence. It could be one from Jakarta NoSQL. I didn't put the package names in it, so can't really tell. But Jakarta Data, while it needs an entity model, doesn't seek to create a new entity model because we already have some really good ones. We have really good ones in a couple of other Jakarta specs. And then, for some other types of data stores, the provider might even bring their own. So we allow for that in Jakarta Data, and these are well-established models. So we leverage that. But Jakarta Data does make some restrictions on how much of the entity model you can use, which is necessary to in relation to how they work with repositories. So if you look at this entity, you have 3 fields on it, and these could be getters and setters and whatnot, and same type of patterns you could use in Jakarta Persistence or Jakarta NoSQL. You have one called an ID, unique identifier, is annotated as an ID. The entity class is annotated as well. Should have mentioned that. ID, name, and price. So these, and we'll be using this particular example entity throughout a number of slides. So I'm letting people absorb it a little bit here. Let's go into the next slide. All right, so then looking at the repository. Repository in Jakarta Data is a Java interface. It is annotated and must be annotated with that repository annotation. And it defines the operations related to entities. And there's more details about repository that we're going to get to, and we have a number of slides to go over those. But in its most basic form, it is just an annotated interface with repository on there. You're probably thinking, well, how does it know which entity it is? And we'll get to that. But so once you have a repository, you can then inject the repository. You can see the repository is named products. You can just inject the products interface into your application and then use it. Let's go to the next slide. So review the core concepts, entity and repository. In Jakarta Data, your applications really don't need to write data access code. They need to do a couple things. They need to define the format of the data, define the data with an entity class, and then define interface methods in a repository to operate on that data. Next slide. All right, so I just say you need to define interface methods. Well, interface methods are actually optional. So for basic cases, that is. So there's a number of built-in repository superclasses in the Jakarta Data API that will give you some boilerplate interface methods that you can just use to get started out of the box. One of those is basic repository. And you can see here, this looks a lot like the other repository. It's annotated. It's an interface, but it's inheriting its interface methods from the basic repository. And you can add more when we'll tell you more about how to do that later. And you'll see that it has some type parameters there. And those type parameters are telling it a couple of things. They're telling it first, what type of entity is this operating on? And then what is its primary key? And those are useful for type safety. So they're useful for a couple other purposes, but in this slide, we're mainly looking at them for type safety. So that when I go and invoke those methods that it gives me, there's like 3 example methods on the bottom: save, find by ID, and delete by ID. And there's half a dozen more that you get out of basic repository. But that gives you type safe access to those variables rather than having to have everything be an object. And then you'll notice that the one thing to call out here is that some of these methods are by ID. There's also an exists by ID. And ID is an alias for whatever is designated as the unique identifier in Jakarta Data. So that's why we can define at least that minimal set of methods operating based on the ID, because that alias can be used on any entity. It doesn't need to have a field named ID. You could have, if you had your ID called product ID, you could have said find by product ID as well. But that won't be in the basic repository, because not every repository is going, or not every entity is going to have something called a product ID. Let's go on to the next one. So that was basic repository, and you saw that it had a save operation on it. That save operation was basically an upsert. It was an update if it's in the database, and it's an insert if it wasn't. And that's a great pattern to have. But not everyone wants that pattern. And there's use cases where you might want to actually separate out that insert and that update. And so we also have the CRUD repository, another built-in super interface for repository to use. So in this case, you can see that instead of inheriting from basic repository, we inherit from the CRUD repository. Same type of deal with the type parameters. And then you get methods like insert and update. And so that is the basic difference there. Let's go into the next one. Next slide. So now we're going to take it in the opposite direction. So we were adding built-in methods. Let's take it in the direction that you don't want any built-in methods. And there's a couple of ways to work with repositories if you don't want any built-in methods. One of those is to use the data repository superclass, which doesn't have any methods. And so why do we have it at all? Why we have it at all is to declare what the entity class is. This primary entity class that should be assumed when you have methods that don't actually tell you what they are. So if you look at this example here, you have delete by ID and exists by ID, which are telling you that you're operating on something with an ID, but you don't know what. The way of knowing what is that type parameter of data repository. And there's some other ways to do that too, which we'll get to in a little bit. So let's go on. Here is the other way. The other way is lifecycle methods. And so we can infer the entity type by looking at the parameter of something called lifecycle methods. So first, let me tell you about lifecycle methods. And we're kind of going through all the methods that you can get out of Jakarta Data without really doing anything, right? So in one case, you inherited to get them. In another case, you annotated to get them. So lifecycle methods are methods that are annotated with a lifecycle annotation. You can see all 4 of them right there: insert, update, delete, and save. And they have an entity parameter, a single entity parameter. So these will also work with multiple of the type of entity. And the way they do that is that the entity parameter could be the entity, like in the add example there, the first one, or it could be a list of the entity that's not shown here, or it could be an array of the entity, including using the varargs format of the last example, the save on the bottom. So that's the format of lifecycle methods. And these, the return types, there's a variety of things you can do with the return types. These are very well documented on those annotations, on the corresponding annotations that you're using. I could also note that when you look at those basic repository and CRUD repository, and you notice they had a save, and they had an insert, and they had an update, and they even have delete, and maybe I didn't show you that one. Those same methods on those interfaces are actually annotated with these annotations. So they have the exact same behavior, whether you brought it yourself and annotated a method with whatever name you wanted, or whether you use the ones from the built-in interface. All right, so we'll hand this back now to Ottavio, who's going to go over some of the finder patterns that we have.
Yes, yes. Thank you, Nathan. So let's talk more about the queries that we can do, right? For example, imagine that I do have my products and I want to query everything. So I want to do several conditions or operations. And the beauty is I don't need to know the database that I'm going to use. I don't need to know the engine that I'm going to use. If I will use SQL, NoSQL, or even REST API, for example. So take this for example. So I have my products interface that extends basic repository, and I'm doing some common queries. For example, exist by name, where I will check if give the parameter name, the information is on the database. And then we have more options in flavors. For example, I can do a find by name and price less than. So as you can see here, we do have our query action that might be find by, delete by, count by, and so on. My empty attribute, as you can see, my conditions, my ands, that could be also or, and then the second condition where I do have my name and my condition. So on this case, I'm doing a query by name that contains the patterns, and the price is less than the value that I return. And that is the build. So here we do have several samples of the capabilities. What we do have in the version 1.1.00. So we can do the count by, we can check if the information is there. So exist by, we can remove information, delete by, we can, of course, do queries, find first 10, and so on. And of course, we can do the order by, as the last sample shows you. So find first 10 by name, like, or order by price, the sender order. So, and that's exactly what I'm doing. Again, am I using SQL? Am I using NoSQL? I don't know. The abstraction will handle that for me. There's the magic of exploring the repository pattern. And indeed, we have even more options. For example, on that scenario here, given I do have a product and I have set two attributes here, the name and the float, I can do the condition as well. So I have the capability to do method by name with the query action, or doing the query matching the parameters. As interface, if you wish, you have the power to create your default methods. For example, you can customize the methods that you do have. For example, I do have my products, and imagine right now that I want to replace what I do have as a product. So I can do the delete, and of course, do the inserts, the new product based on that. Um, and finally, what I do have here is the annotation query language method. So on this case, the native one will handle for you. Or right now I'm using GPQL, but you can use any query that you provide my support. For example, NoSQL, Cassandra, and so on. So on that case, I can search and operate any kind of query, as you can see, with my parameter. And we, of course, have the power and the capability to define the order, and also to define, for on this case here, I want find price between two values, and define the order. So descending price, ascending name, and ascending ID. It's like a magic, right? So we have the power to define limitations as well. So we can order to the limitation, and yes, you can do pagination as well, right, Nathan? So can you explain more about this magic behind the pagination for us?
Sure. So if you thought about the previous two slides, you went first through sorting, right? Sort in various orders and all that. And then you went through a limit. And putting those two together, if your sort criteria is such that it uniquely identifies the entity, right? So that you have a deterministic sort ordering, and you think of, well, a limit could get you basically the first page, but if you want to keep reading more pages after that, we have a structure for that. It's called pageable, where you can request individual pages. It's a couple forms of pagination as well. So this one here is looking at something called offset pagination. It uses the page type. That's sort of circled, squarish circle with the first box there, page of product. And you can see that the page request parameter, which is a pageable, the pageable is created with, it has a particular size, and then it sorts by that ordering of sort criteria.
So, so let's talk about more about the pagination, right? So instead of doing everything by the bare hand, you can do it magically. So we have two kind of pagination. The first one is with offset. So you can define the number of elements in the the page that you're gonna read and check the information. Okay, so that's the one. And of course, you can skip, you can navigate this information. So instead of you do returning 1,000 elements, you can limit this query and define what you need to that time. For example, do a query 10 by 10, 11 by 11, instead of you bring a huge amount of information, especially because remember, we do have to serialize that information to Java. So if you just return what you need, you're gonna save a lot of time on the mapping and also in the database. We also do have the key set cursor pagination. So it's an alternative. So it's more efficient. So especially because no need to a scan. It's basically by the 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 key set information, right? And of course, with that kind of optimization, we have flavor to choose. Again, everything that we take here has a trade-off. Analyze, understand, and take the best option that fits for you. Okay, Nathan, do you want to go ahead here, explain a little bit more about the
All
key
right, so
set
this is just,
cursor?
yeah, an example of using the key set cursor-based pagination. And if you think about this example versus the one we looked at a little bit ago with offset pagination, it's almost the same thing, right? So these very much have the same look and feel. They use a lot of the same API. In fact, they can even be used interchangeably in a few ways. So what's happening here is, in this case, you see that first circled type there is not a page. It's something called a key set aware page, which basically inherits from the other one. But that is the signal that you want your page not to just be offset based, but to actually have awareness of cursors on it. So you can obtain your first page if you want to with offset pagination. But as long as it's key set aware, you'll have cursors on it. And then you can switch over to key set based pagination after that. Or you can just directly go and get a cursor to begin with. You have both options, and both have their place. So if you look at this, it looks very much the same. And you look at the pagination request here is the same. I mean, it's using an offset to start out. And the entire rest of the usage is actually the same. It's just the return type in this case. But this gave you this gave you the cursor-based pagination, which will avoid, or can in some cases avoid the skips and duplicates that were covered on the previous slide. All right, let's go on to the next slide. All right, so we're halfway through here. So let's go to the demos. The first demo, and I don't know if you saw the link there. There's actually a link to a demo app that you guys can run this one yourself if you want to. But I'm not going to ask you to put that back up because I need to share my screen to show the demo. Maybe we can post it in the chat at some point. So I'm going to share. Can you see this here?
Yes, we can.
All right, great. So this is a demo application written to run in Open Liberty using Jakarta Data. It was written by one of the committers to the spec, Mark Swatosh. He did a great job with it. And I'm going to take you through the entity, the repository, a little bit of how it's being used, show it being used live, and then make a few live changes to it. So hopefully I remember to start the server, right? So here we have an entity, and it's a pretty simple entity. It has the entity annotation. In fact, this is a JPA entity. Sorry, Jakarta persistence entity. You could even see the imports up there. And it has a number of annotations, but not all those annotations actually came from Jakarta persistence. The only one that came from Jakarta persistence are entity and ID. The other three came from Jakarta validation. And so these are putting constraints on here. The one I'm going to ask you to look at, because I'll show it in the demo, is that this ID has to be a positive number. And so Jakarta Data has integration with a number of other, it defines integration with a number of other Jakarta specs, one of those being Jakarta validation. And so we're going to show you that as one of the things in this demo. So what to think about here is your crew member. This is definitely Jakarta themed. It's like sailboats and stuff. So you have a name for the crew member. You have a rank for the crew member. This is an enumeration. I think it has 3 things in it. You'll see that later. And then it has a unique identifier, a crew ID. So just those 3 aspects of this entity, and it doesn't get more complicated, but it's nice for a demo to be small and concise. And then we'll look at our repository. We created a repository for this one. In this case, I didn't have it extend any of the built-in interfaces. I just put all the methods there so you can see them all yourself. So what you can see is it has a save operation, one of the lifecycle operations. It's using the save annotation. And in it, I passed in an entity like I'm supposed to. And I also annotated that with bean validation at valid so that the Jakarta data provider, that's a signal to it to automatically validate that thing when it's told to save something. I could have put that valid annotation on the result. I'm going to assume that the result's valid if it came in valid, right? So you can use bean validation in a lot of places. Jakarta validation, that is. Then we have a find by rank, passing in an instance of the rank enumeration. With that, you have a list. You could have multiple different entities that have that same rank, right? We have just a find everything method, and this is using the find by rank was queried by method name. Here we have yet another pattern, which is the find by parameters. And so find by parameters with no parameters has nothing to qualify by. So it finds everything. So this could be named anything what you want to. It's a find method. We put in there how to order it. You're returning a stream in that case. The next one here, we're doing a delete by the ID, and then a delete everything. I don't think we actually use delete everything in the example. Otherwise we wouldn't have any data to show. So then there's this service with a bunch of basically REST endpoints that go in. So like you can see this one, it just invokes the find by rank method when you send in a rank, right? So there's a variety of these things. So let's switch over to the app for this thing, and we'll show some of this working. So, and you're going to get to trust me that's doing what I say it's going to do. So let's make it violate the bean validation constraint. Let's put any negative number we want to, right? And so did it add it? Well, if you were watching up in the right-hand corner, I'll do it again because you might not have seen it. Right up in the right-hand corner, it refuses to do it, and it says ID number must be a non-negative. So we'll fix that and make it something else. Make it a big long number. And we'll register that one. You can see that this thing is also, running a find all method, and it's going to show you everything. And it just showed up right there. Looks like Jakarta Jack. He's a captain. Maybe I didn't want him to be a captain. Maybe I wanted him to be something else. How about an engineer? And so if you remember, save is well, if it's there, update it. If it's not there, then insert it. And we got an insert. Let's update it. So there, the find all ran. And this application is automatically running that as well. I went and updated it. So you saw the find all. Let's do the find by rank. And this is actually invoking find by rank 3 times, one with each of the ranks. So here we go. We see all the captains. We see a number of officers. We see only two engineers. One of those is the one we added right on the bottom there. So this application. So we'll change some stuff in it. And so let's switch over to we can look at these things. We can just invoke the REST endpoints. I just refreshed the one for engineer, and Jakarta Jack showed up. Anyone remember what the other things were? I think officer was one of them. There we go. And captain. Oh, there's a lot of captains. So maybe it would be nice if we could return the captains, or just anything, the rank, as in pages, because we don't want to return so many at once. So let's do that. So we'll go take a look first at our repository. We're going to need something that does that for us. So it's very similar to this. We're just wanting to find by rank, except that we want to return a page rather than a list. And to request a page, I'm going to need a page request. We'll select that one. Call it page request. Okay. So find by rank, also accepting a page request. So that should be all I needed to do. I didn't need to write any data access code. I just defined an interface. Now let's use it. So if we look at what we have here, let's copy the method that invokes that, and we'll write another one. So let's use a path parameter again. Hopefully I don't make any typos. That was a typo. Page num. We do it by numbers, not names. And yeah, we'll probably need another one of those. So what did I call it? I'm going to use copy and paste to be safe. So that was the REST part of this. That's not a demo of REST. So thank you for sitting through that. And now let's go and actually make it return a page. So instead of list, we'll have it be a page. I will name it more nicely to make it clear what it is. And this is very close to what we have, but we had another parameter, right? Page request. So we're going to need a page request. Page request is a pageable, right? What did I call it? Page rec. And we can do that in Jakarta Data. Pageable of size. Size do you want? How about 6? That sound good, Ottavio?
Yes, sounds good.
Okay.
How about 11? Just to celebrate the newest version with the newest
This is going to prove this is live, and they're not just faking it. It got changed on me there. Okay, so and then what do we want to do? Sort by?
Yeah, sounds good.
We'll sort it by sort.ascending on, sort them by name. That's easy to tell if we did it right. Okay.
Yeah.
And then if they happen to have the same name, sort.ascending on the, is it crew ID? I could do crew ID or ID. Remember, it's an alias. All right. Any syntax errors? Last chance before I try it. All right, let's save that thing.
Go, 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 go.
Yeah, there is a syntax error. Guess what it is? Of size. Because my fluent method needs a dot sort by. I'm sorry, you guys can't see the compilation, but now it has actually compiled, and we'll go have a look at it. So this is it right here. So we don't want page 5. I want page 1. Are there 11 things on it? Man, you gave me a big number. We got to count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ended with the Gilligan's Island guy. 10, Nemo. 11, Pugwash. Now let's go to page 2. That is not page 2, is it? What did I just do? All right, we had a little problem here. That's not what I expected to see. You know what we did wrong? Guess what we did wrong? We didn't
Yeah,
which
you
page we wanted. So it
just
defaulted
hit
to
the
1.
page. Yes, exactly.
Yep. Pageable of size 11. Page number, not 1. We want to actually use our path parameter. Don't you love live demos? At least we found it out right away. And it's not page name, it's page num. So I knew I should have just copy and pasted code, so I need to get it right. And are we looking at everything correctly here?
Yes, I think so. It's working.
All right, let's format it a little bit better. And it still says I have a compile error.
Because you are returning string instead of long in the pay line 89.
Oh, that's right. Good one. Now it compiles. Thank you. Save my demo.
Wow.
All right. So now let's look at page number 2. We only have 3 things on it. And we'll look at page number 1. We have the 11 that we thought we did first because it was defaulting to page 1 when we didn't tell it which one. So there you are. All right, we'll hand it back to Otavio for his demo.
Whoa, it's working. Super magic. So let's start. Let's do a quick demo because we don't have enough time. And let me share here the screen. So let's first create the boot in presentation mode, as you can see. So basically, I won't do everything by scratch, but the goal is I create a simple Java SE application where we're gonna feed it with Pokemons. So I do have my Pokemon entity here where it is working with records. The annotation that I'm using here is from NoSQL, Jakarta NoSQL specification. We do have the Pokemon with ID, name, and location. As you can see, I do have a factor method to create my Pokemon. So the Pokemon you create with ID, name, and location. My Pokemon do have my repository where I can use several methods, and also I can do a find by name. Um, go quickly here on my service. So I'm using Java 17. Here we do have several minimum requirements to run with Java SE. So CDI or the implementation. On this case, I'm using Weld, JSON Bean because I will work with JSON. So I'm using Yanson. The small y configuration to work with configuration, but outside the specification is more around the implementation itself. And I do have a couple of implementations. So MongoDB, Couchbase, ArongDB, because this code, I do have 3 NoSQL database to work with. So I have the common configurations. I can select the provider. If you remember very well, Eclipse microprofile configuration, you can override everything by environment. So in production, for example, you can put password, you can put whatever you want. And me as a developer does not need to know about this kind of detail. So I will have my SE container. As you can see, I will inject my Pokemon. And finally, I will save and then find by Pikachu. Hopefully, I will create some Pikachu Pokemon. Otherwise, just make sure I will return all the Pokemons. So start returning all the Pokemons. On that case, I will do the find all, just so you see. No, let's do it better here. So I will come here and then do the for each. Thank you. And that is it. So let's work. Let's pray to work. So it's not working. Let's see what's going on. Oops. So it's not working. Let's see why. This my Docker container is not working. Let's put up and let's see what's going on right now. So I do have my Pokemon. I do have my repository. And let's work. No, just one. So let's just comment this line here to return all the Pokemon and see what's going on. If it's not working, sorry, it's the issue of the live. Anyway, I will publish the code working on the GitHub. This way, you're gonna have time for the questions. Yes, that is the issue with the live demo thing.
Yeah, no problem. It looks like we have 3 questions. It looks like
Yes.
we'll go to the easy ones first. Do we have a between comparison operator and greater than and less than and greater than equal and less than equals? And the answer is yes, we have every single one of those in Jakarta Data. They're all standardized. Let's see. You want me to ask you the other question? The other one says, what about dynamic query parameters? How do I know if my name results in the correct query? Isn't that a bit unreliable? And what about changes in query? Would that mean changing the name?
Okay, that's a good question. As everything has trade-off, right? In this version, we do not have time to finish the meta model engine to avoid this kind of issues. However, that will be the next move to the next version where we're gonna release this version, this feature. So this way, we don't need to use string. You can use these fields, and as soon as you change the fields, it will change the information for you.
Yeah, but I also wanted to clarify then along those lines that in that slide that we went through really fast with the query parameters, we didn't just have name parameters. We also do have positional parameters. So if you're using something like JPQL, you have the question 1, question 2, and so forth, where you're not needing to type in a particular name or name them a particular thing, if that helps at all. All right,
There's
so
no question.
another question showed up right at the last second here. It says, so in Jakarta Data, the query language, will it be standardized across all persistence providers and frameworks? No, it will not. So Jakarta Persistence already has its own query language, which is very good and very suited to the feature set that's in Jakarta Persistence. If you're using Jakarta Persistence backed provider, you use JPQL. If you're using Jakarta NoSQL, you use one of the query languages that's appropriate to whichever database you have. And some of them may not have any. So there is no standardized query language. All of the standardization is done with our query by method name patterns and other, the other capabilities that are standardized within Jakarta Data itself. All right, do we have any other questions? Last chance.
Give once.
All right, it says no more questions. All right, thanks everyone for attending, and give Jakarta Data a try and tell us what you think, and we can, see how we can improve it.
Yes, that's amazing. See you guys around and have wonderful cake. in cookie.
Great ending.